Hello, everybody. I introduce myself. I'm Dr. Bouras Abdelkarim. Thank you to give me the opportunity to present my research work titled Fault Detection Technique for On-Gene Safety and Diagnosis. Today, industrial maintenance responds to costs, deadline, and quality. For this, the survival of electromechanical system in industrial environment is a fundamental task, in particular for those of high caliber, where downtime is very critical given their importance. As a result of mechanical and operating constraints, induction motors used in industrial applications are often subject to mechanical and electrical faults. These faults, if not detected and corrected at time, can cause degradation and insecurity for the entire installation. Following mechanical alteration, these systems are often subject to bearing defect, which represent the majority of degradation and which affect the other part of the machine. More failure detection techniques are used in industry. Our contribution is focused on the detection of electromechanical system faults, and that by multi-technique. For that, the precise extraction of information relating of this failure research has been particularly directed toward MCSA, motor current signal analysis. To extract precisely the information relating to the failure by MCSA, a current sensor is integrated here into the source of the machine. The signal will be transmitted to the surveillance system, which analyzes the signal by algorithm. The result presented informs us about the severity and the nature of the faults. This slide presents the test bench. The experimental test campaign was carried out in a several stages. The initial test concerned the extraction of the current signal during undergrounded operation and of the motor, then during the presence of degradation of the bearing ball and the cage. The signal for diagnosis were occurred by oscilloscope connected to AC/DC current clamp. The presentation of the different spectra was obtained using program written in MATLAB environment. This slide presents the experimental results. When the system is operating without the presence of any degradation and under ideal condition, the pattern will be a perfect circle since the amplitude of the compound of the current vector will be equal, like here. As soon as the system undergoes any degradation, the corresponding characteristic orbit tends toward a narrowing accompanied by a thickening compared with the orbit obtained in the healthy case of a machine. This slide shows the GT spectrogram of the healthy motor ending the case of cage, outer race and inner race faults of the bearing. By comparing the experimental result obtained, we observed on the spectrogram a variation of the color of the band corresponding to the frequency of the fault. The reading of each of the color scale shows evolution of the noise density when passing from the healthy stage to the degraded state. Conclusion. This article focused on experimental investigation into the detection of mechanical faults in the variable speed induction motor system through the simultaneous application of MCSA. The result obtained proved that the application of MCSA is sufficient and effective to detect mechanical defects. Our perspective focused on the integration of this approach in industrial application in order to optimize the diagnosis and detection of faults. This will be achievable thanks to automated systems capable of ensuring reliable diagnosis and predictive detection. Thank you for your attention.